Indulge us to start, Charlie. Can you paint a world that you are fearful of if AGI does occur?
So I would like to take the opportunity with this question to describe some fears that are not relevant to real life AGI. And I feel like these kinds of fears come up a lot in discussions, but they're not really relevant. Specifically, we're just gonna talk about Skynet. We're just gonna talk about the Terminator, because the Terminator is not a documentary. It is a work of fiction. It did not happen. It is a story to entertain viewers. There is no basis in reality that an artificial general intelligence would want to destroy the world or destroy all humanity. That is a fanciful scenario created for the movie. So whenever people talk about artificial general intelligence, Skynet always comes up, and I feel like it shouldn't. So more realistic fears are ways in which these kinds of intelligence is used against people in real life, and the way that a more sophisticated, faster analytics tool would be able to augment these. The kinds of, these are called dark patterns or unfriendly design, where interfaces are designed in a way to trick users into doing things that they would not do. This is obvious in things like, phishing links or those kinds of fake ads, but it's also incorporated into more legitimate design. Amazon got in trouble for tricking users into signing up for Prime deals that are more expensive than the value they were getting out of it. Facebook is constantly getting in trouble for using disingenuous design to trick users into giving up more information. And the more information that they give up, the more training data that Facebook can use to understand human behavior. A generally intelligent system would be able to find even more of these patterns, even more of these things institutions and corporations can use to direct human behavior in ways that suit them, which is giving them more money.
And that's probably going to be a topic that we hear more and more about, the money aspect and the benefit from it. So you're saying the Skynet thing, fantasy, it's fiction. It's not.
It is fiction. And I do think it is worth, even if we indulge the fiction, I do think it's worth noting that the actual story of the Terminator is not about an AI that humans built that spontaneously decided to destroy the world one day. Skynet was a military project in the story. Skynet was a brand new intelligence that humanity gave nukes instead of hands and paranoid combat scenarios instead of social interaction, and then everyone acted surprised when violence was the only way it knew how to interact with the world. Again, it's fiction, but people should at least try and understand the fiction they keep invoking.
I wonder if there's a combination of that military aspect and this superior data and algorithms that occurs. Do you want to take that to start? You want to kind of picture what could happen there?
It's true. There are facial recognition systems that are linked to weapons, that machines that can automatically detect, select targets.
Mm-hmm.
There are automated military drones.
Yep, drones.
Have automated systems that decide whether or not, well, just to say it, whether or not they kill somebody. And if we're thinking of general intelligence as a system that can implement a solution start to finish without any kind of input,
mm-hmm.
that is a large black box of unaccountable decisions. That infamous slide from an IBM presentation from the 1970s, a machine can never be held accountable, so a machine should never make a management decision. So if the whole decision chain is automated, is that for optimal use, or is that to obfuscate blame when something goes wrong?
Interesting. That's a great way to start it. I have to tag Lee in on this, though. Lee and I were actually talking just this morning about some of these scenarios as well. So Lee, in a few lines here, what are some things that you think of with AGI on more so potentially the scary side of things?
Well, Rich, thank you. Solid question. I think what Charles is talking about here is so true. And I think we're on the same page. When you're creating this technology, the goal of the technology is normally for good, right? But the way that good can be repurposed is it's tough. It's tough, right? As you're building things, they can do more than what your initial intention was. So when we talk, you had mentioned Skynet, spot on example as far as what the worst things that AGI could do. But I don't feel that we're too far away from that. And the reason that I bring it up is because from a technology standpoint, oftentimes technological advances can be mistakes, like the X-ray, right? Somebody was looking into space and then suddenly we figured out the X-ray is great for our bodies, right? Being able to see and not have invasive things happen. So there is some good that can come from these mistakes. But as you mentioned with Skynet, along the way, they leave this virus and then you go back to Skynet and say, hey, Skynet, fix the virus, kill the virus. But Skynet says, you want me to kill myself? You must be the enemy, right? That is a situation. That's a wild situation. But I think what we're really getting at in that whole scenario is that we can't put the genie back in the bottle. That's the key that's happening here. We don't get to choose not to have the technology, right? We only get to choose what we do with it. So that's the scary part. Another scary part for me that I think about is Sims. I may be older. You guys know Sims?
Oh, yeah.
Yeah. Right. I never thought that I could live in a simulated environment, right? I played the game, but if my choices are already being pre-selected and filtered for me, meaning the movies that I watch, meaning the route that I choose to drive to work, or the news that I'm getting, right? That's being chosen for me. Am I already living in an AI world? And if so, what kind? Right? Because does a fish really know they're in water? Right? That kind of thing. So lethal autonomous weapons issue, geopolitical tensions. What could happen with AGI? Huge issue. I call it runaway intelligence, right? Intelligence that gets away from us to the point that human oversight becomes impossible. Possible issue here. Alignment problems, existential risks and opportunities are there. I do want to caveat this in saying, as I take off my tinfoil hat, that all the bad that I'm talking about here could also be repurposed for good. I hope that kind of makes sense.
That does make sense. And you actually kind of gave us a little bit of a preview of a handful of the topics we're going to discuss just today, too. So now that, thank you, Lee, Charles and Lee have obviously painted this type of, we'll say, bleak scenario in certain situations, but also a little bit of level setting. So I thank you both for that. I wanted to turn it over to Jamison. Jamison, now that we have this potential of danger that could occur, we'll talk about positive. Trust me, we're not going to all be doom and gloom. But can you just share with us what AGI is for those folks who may not know what it is, who may confuse it with Gen AI, right? What is AGI?
Yeah, that is a big question for sure. I do want to start off just by adding in a little bit from the previous question that we were talking about.
Sure.
DARPA is actually one of the largest funders and has been since pretty much the 50s when AI was founded for AI research. And they tend to put on particular competitions to try and get new models out there, pretty much from the 50s and 60s up to the 2000s with some of the autonomous vehicle challenges that they put out. So it really isn't too far from reality that military does have a heavy hand when it comes to just AI development in general, for sure. But another thing that I wanted to bring up was a quote in the 1960s by an AI pioneer named Norbert Wiener. He says, "If we use to achieve our purposes a mechanical agency with whose operation we cannot interfere effectively, we had better be quite sure that the purpose put into the machine is the purpose which we really desire." And I'm sure that we'll get back to that for sure. But those are just my 2 cents on that particular topic. It is a reality, of course, that military is involved, but at the same time, just as Lee said, it's a double-edged sword, right? It can be used for good and for bad, just like pretty much all technology, right?
Mm-hmm.
But getting back to the AGI question, what exactly is AGI? There's definitely a whole bunch of talk right now in popular culture and discourse in general about artificial general intelligence. That's what AGI stands for, as opposed to generative AI, which is a different subfield, I would say, of artificial intelligence. Now, I would say that I take a bit more of an academic perspective when it comes to AGI. I read a lot of research papers, a lot of literature regarding just intelligence in general, because I am consistently curious about it. And it seems like it's something that we haven't really figured out too much. It's not necessarily a pseudoscience, but it's also something that we intuitively understand, as all humans are intelligent, right? But it's not something that we're able to really fully define. And that really affects how exactly we go forward when it comes to trying to recreate that from a mechanical perspective. But in general, I think with what pop culture and with what academics both agree on in terms of what AGI really is it's a subfield of artificial intelligence that focuses a lot more on making models that can do a lot of different things, right? Not just one particular thing, but a whole variety of different things. And of course, there's a spectrum in terms of what generalizable really means. But I wanted to point out one particular paper. It is a gigantic paper. I think it's about 60 pages long or so. It is called On the Measure of Intelligence, and it's by Francois Chollet. It was published in 2019 or so, so it's pretty recent, pretty recent, I would say. Recent enough, at least. And Francois Chollet was actually, for those of you who know Keras in the audience, who are at least a little bit into deep learning, Keras is a library that a lot of people, especially data scientists, of course, use to create models nowadays. So this guy knows what he's talking about. This guy knows his stuff. And this paper is essentially a proposal for a new data set. But the first 40 pages or so are pretty much trying to lay out what people think about intelligence in the academic perspective, what kinds of things people have written so far. And he goes into generalizability to be able to turn a particular model into something that can be used for a bunch of different things. And he uses a couple of different terms. The first two that I want to talk about are strong AI versus narrow AI. Now, narrow AI is basically a model that can essentially, or program, of course, that can do a particular task, but really focuses on that one single task, as opposed to strong AI, which has the intelligence to basically generalize its own knowledge to a variety of different tasks and its own pattern recognition to a whole bunch of different things, maybe in one particular field, or hopefully eventually into a lot of different areas. And so that's kind of the major difference between narrow and strong. We have a lot of really, really good narrow AI programs now, and models. One of them would be, let's see, AlphaFold is one that I can think of that comes to mind right now. That is made by Google DeepMind. Google Research has been working on a model that can essentially predict particular protein conformations so that we can use that in drug testing and pharmaceutical industries to better understand how the drugs that we create interact with the proteins in our body. And AlphaFold, I believe, is considered a super intelligent AI. But the thing is, it's a very narrow AI still. It really only applies itself to that particular problem of generating new proteins to experiment with. Now, that doesn't necessarily mean that it's not influential if it's narrow. It's definitely being used quite a bit in research. And this is where we're seeing a whole bunch of really great improvement with AI, the good side, I would say, mostly in the medical industry for sure, and pharmaceuticals and whatnot. But it is super intelligent because it is better than 100% of humans who can do the same thing, right? It is faster for one thing. It is more creative in a sense to be able to create all of these different proteins. But again, it's just narrow. It's not dangerous in any regard in terms of what it's being used for. I'm sure somebody could probably come up with some kind of use case that would be a little bit more malign or malignant, but it would be difficult because it's really tuned specifically for this use case. Now, when it comes to strong AI, when we start to try and create models that are more flexible and more generalizable, that is when the double-edged sword sort of comes into play, right? Because we have, for example, all of the different chatbot models, the different large language models nowadays. We consider those a little bit more generally intelligent just because they're able to apply their knowledge in a lot of different use cases. Now, one reason that is the case is because they rely heavily on language data, and they are language models, right? It's in the name. And language for humans is the hub of all ideas, right? And so it's pretty easy to both get data and create data in this regard, in a variety of different situations like conversations or particular formats of documents, all of that kind of stuff. So in that regard, large language models are generally intelligent. But again, this is sort of a ramping up kind of thing. You know, it's kind of like saying we can use these large language models in a lot of cases, but really only if you're interacting with the model through a screen, right? Unless you have something that's actually created, like a robot that actually has the model hooked up to it that it can use, you're not necessarily interacting with that in any way, shape, or form besides language, right? So when it comes to AGI, that's one step that we have here, but there's a whole bunch more to AGI that we will most likely get to eventually. Right now, it's still very much in its early stages, but it's really just about, when it comes down to it, it's about being able to take the particular model and put it in a variety of different situations and get it to make what you want it to make or do what you want it to do. I think a really good analogy, just to sum things up really quickly, is basically having, this is a great example, especially for machine learning, because we use games a lot in machine learning. But say you're playing a game, you're on a particular level, you have to kind of learn how to play through the level before you're really confident with it. And then if you play it again, the same exact level, it's a little easier because you know what to expect, you know what exactly you're supposed to do. Now that in particular problem, let's say that's one particular task, we can of course get models to play through a particular level. It's a little bit more difficult to get a model to understand the game to the point where it can play a new level successfully, right? And that is where the robustness of particular models come into play, and the flexibility of particular models. And then being able to generalize that even more, not just for one game, but for a variety of different games. That's even more difficult, right? So that's kind of the problem that we're dealing with right now, is being able to take one particular model to whole new heights by applying it to a completely different use case. I know that was kind of a lot, but does that make sense overall?
I mean, look, you gave us an absolute ton. One of my biggest takeaways was you read 40 pages of that report just straight the whole time, that one you were talking about.
Oh yeah, I've read through that one multiple times. It's really good. I would recommend it. It's a little dense, but at the same time, there's a lot of insight into intelligence in general.
Cool. And we'll certainly share the link right here. The area that I actually wanted to narrow down in, just the pure kind of layman's, yep, you saw what I did, pure layman's term of AGI, right? When I'm going through and just doing one quick sentence, AI has the ability to understand, learn, apply knowledge, and it's all at a level comparable to humans. If we had to sum that up in one quick line, is that fitting?
I'd say that's really fitting, especially the human part. That's definitely something that we can talk about a little bit later as well. When it comes down to alignment, but I think that's a pretty fitting single sentence definition.
Great. And when we get to the alignment piece as well, I'm also going to be interested. You mentioned a couple levels. There's levels of super intelligence. I think you mentioned we're at a certain level. We'll visit that. That is incredibly interesting. That seems to be almost a uniform understanding, but we'll dive into that. I do want to jump over to Lee as we all digest all that information as well. Lee, currently there's an article just about a month or two ago. Sam Altman basically says he doesn't care how much it costs. Now, it may not be his money, how much it costs to achieve AGI. He's pushing for it, obviously. How close do you feel, and you almost hinted at it earlier, or do you feel that we are at achieving AGI? Is this something 5, 10, 50 years down the line, or maybe even sooner?
It's a great question, Rich. A lot of people are asking this question. I like to kind of reframe how we look at AGI, though, right? Instead of it being some finish line that we cross, I like to think of it more like mile markers on the highway, right? We're at mile marker 12, then 13 and 14, but there really is no destination in the same sense, right? So now if we're going to consider AGI not to be some final destination thing that we're trying to get to, we're going to consider to be mile markers, then we have to ask ourselves, well, what will the mile markers be? And those oftentimes are going to be cognitive tasks that humans do, right? So now we have to ask ourselves, what are those cognitive tasks that humans do that we now want a computer to be able to simulate, right? So for instance, I can go, I would want to take an AGI system. I'd want to ask it to build me an online marketplace and an e-commerce platform similar to eBay, right? And I want you to build it from simple instructions for me. So I'm not telling you about the infrastructure. I'm not giving you all the details on how many servers that you need. What is the code that needs to be put into this deployment, release, updates. I'm not giving you any of that. I'm just giving you a task to do. That's one way. That's AGI. That would be an AGI scenario, right, of application that could be used. Or if we're talking levels, another level could be for that same AGI system. Say I want to go on vacation. I want not only you to build my application, but I want you to run my business for the next 7 days. Or how about this? Run it forever, right? So as far as the levels of what you would want AGI to do, you need to kind of define that. Rich, you had mentioned before, and Jamison was talking about it. There are within AGI, you can have something called super intelligence, and then you have levels of that, right? But from a super intelligence standpoint, that's a whole can of worms. You want to go back into ethics considerations on that? That's wild. That's wild. But to answer your question, if I can keep it, simple.
Keep it going. You're blending the stuff here. This is great. Keep it going. Yeah.
Okay. So if you're telling me the definition of AGI is taking a math test or history exam, medical, law exam, LSAT, what do we take in high school? SATs? Yeah. That kind of thing. Yeah. If you're telling me that this is what you want AGI to be able to do, as per, and I'll send you the link over, but coming straight from OpenAI's crew, Microsoft said similar numbers, right around 5 years. In 5 years' time, that's what they're projecting, right? This is what they're doing. Not my words, their words. But I mean, even right now, I think ChatGPT, didn't it pass the Turing test? I think it did. So it's already getting close, right? But if you're asking me if AGI is going to have human intelligence, I'm not sure how we specify human intelligence on a scale. So I'm not sure how to answer that question confidently. And so I answer what I can, but the other piece, I don't know. I'm not there yet.
I love that response because we probably shouldn't know right now. There was a Forbes article where they'll say we'll never achieve AGI. And some of the factors were the human pieces that we don't even understand about ourselves, how our neural networks work, how brain simulations work, understanding human cognition. All of that is not there for us, but we're saying that would be pieces that could actually create that next breakthrough to get to AGI. I see a couple other responses at the same time. Charles, do you want to tag in and add a point there?
So just a couple thoughts. I think it is in the context of business, in the context of mundane interactions. I think it is useful to define AGI as, well, for lack of a better term, a secretary. The boss tells the secretary, hey, do this, and then the secretary takes the steps to get that done. So if the internality of the agent that is doing that is not important, we're talking like when you're talking about like human intelligence, that is a very different conversation compared to achieving a task as well as a human. So in this context, I think it's useful to think of AGI not as a machine, but a series of potentially interlocking systems that achieve an outcome. I think the phrase achieve AGI is a little misleading, as Lee was saying. It is a granular process. You are trying to get to the point where you can achieve certain business critical tasks with the effect of a human. Does that make sense?
Yeah, it makes sense. I mean, if you look at the book Co-Intelligence by Ethan Malik, right? He mentions Gen AI. You look at that as an intern. Now, going to your part where you're saying AGI as a secretary, can do a little bit more. I'm picturing, and correct me if I'm wrong, I'm going to ask a genuine question, are AI agents, which are kind of hey, somebody will go set up your whole travel IT. That is not necessarily kind of the further results of AGI that we kind of picture when we think about it, right? That is something that is achievable fairly much so here and now, relatively soon, if not already, correct?
Correct, yeah. Just because the other thing that we have to keep in mind is that a lot of our most sophisticated systems now rely on precedent. What tasks have humans done a lot that a machine learning system can extrapolate from, can cluster behaviors from millions of other behaviors that were taken. If we look at tasks that have this huge precedent, then our current systems are really good at understanding and implementing those because we have really good machine learning algorithms that can learn from that. We also have any system that can be defined into rules, just a checklist. That's also something that can be generalized really efficiently. So I think it's really more at this at this stage, we have to look at our cognitive tasks and separate them into what kind of intelligence does this take? Is it rules? We're good at that. Is there a lot of precedent? We're good at that. Does it require some kind of inventiveness? That is something that machines aren't good at yet. So it might even be more useful to think of the most efficient path forward would be to hybridize workloads rather than going for this moonshot of a robot that can do everything you want. What are machines good at efficiently, energy efficiently? Keep that in mind. Versus what are humans good at efficiently, time efficiently, and energy efficiently. There is one more thing I wanted to bring up, and I think it is kind of an important, it is kind of an important side note. Lee brought it up. I want to talk a little bit about the Turing test, because Alan Turing was brilliant. I do not have the words to describe what a genius Alan Turing was. He was just invented computers as we know them. Brilliant man. But the Turing test is a philosophical argument, because at the time, cognitive tasks, popular consciousness, in like the 30s and 40s, was that cognitive tasks could only be done by humans, because automated processes were restricted to things like assembly lines, mechanical processes. Cognitive tasks were exclusively the domain of humans, and Alan Turing proposed a machine that could simulate a cognitive task. Passing the Turing test is actually really, really easy for a computer, because it is really easy to trick the average person into thinking they're talking to a computer. They're not talking to a computer. We know that. So the Turing test has been given this mythological significance in popular culture, when that's not really what Alan Turing intended. It was very much a philosophical argument of the time. And I think that is an important caveat when we're talking about that specifically.
Cool. Two follow-up questions, and this is great where this is going. Can you give me one or two lines? What is the Turing test? Just nice and clear.
So the Turing test is, you have a participant at an interface.
Say a computer, you're saying, right? Like say or a robot, or
yeah. Of course, when Turing was written, it was like tapes and big drums. We're thinking the computers. Yeah. He didn't invent them yet. And the responses coming out of the interface convince the participant that they are interacting with a real person, when in fact they are only interacting with an automated system.
Perfect.
So it's about, the Turing test is not a measure of cognitive ability, it's a measure of human perception. Does that make sense?
That makes sense. And to put a little bit of a cherry on that, wasn't one of the first times that this was achieved, and I say it somewhat in quotes, was when the machine was pretending to be a young boy, and it was tricking the people who were interacting with it, and they started believing that they were actually speaking to a young child, and young, maybe 13 or younger. And so the, I guess, survey or whatever what was conducted said that they believed that they were talking to a human. And the reason why is because it is a lot easier to pretend to be a child who can say, well, I'm not sure, or explain things kind of maybe silly, and trick humans. And though it was in that type of capacity, it technically passed the Turing test. Are any of you familiar with that? I know it's a very vague example? I see Jamison shaking your head.
I can't remember that specific example, but I basically, to me, it seems like ever since we had like the first chatbots, which were pretty much in the 50s and 60s, there have been particular scenarios where it can be relatively easy to fool a person into thinking that they're talking to a human. I think the more important aspect is how much they're primed before the experiment starts, before that study starts, with like basically being told you are going to be interacting with either a human or a machine, or not being told that at all, or even basically being told you will be interacting with a machine. Like all of those three things turn out to be completely different studies when you look at it. But I think that particular scenario I'm not completely familiar with, but I would not be too surprised if that was the case.
And I like the way you say they're kind of prepped ahead of time. Another one where that occurred was when the machine was pretending to be a psychiatrist.
Yeah. Yep.
Right.
Yep.
That was another one.
Yeah. I'm forgetting what the name for that one was.
Charles? Yeah, go ahead.
I love the Eliza study.
Eliza, that's it. Yep.
Because it is, if you look at the results, actually very funny. Eliza was built by the name escapes me. I apologize. The person who built Eliza built it to kind of disprove a model of psychological care at the time. Very general questions, allowing the subject to just kind of vent. So and his complaint was that this system is not actually psychological care. A robot could do that and have the same effect. So he designed the Eliza study to kind of prove that this was not an effective means of psychoanalysis. But the participants loved Eliza. Participants really,
you're right.
Yeah, participants actually actually found it really therapeutic to have a machine say, "I understand your concerns. Please continue." And my personal analysis of the Eliza study is that it turns out humans just love screaming into a non-judgmental void.
That's true. Yeah. It's a very interesting study. A couple other aspects. I want to get back to Lee's question, and he had some great points. When I mentioned you're blending everything together, it worked out great. But check out the Eliza study. You're talking about putting the level of AGI at checkpoints instead of finish lines, in essence. And there is a current definition, I believe, provided by OpenAI, correct me if I'm wrong, 5 levels of superintelligence. And going back to, I want to maybe throw this back at you, Lee, as well, is, some of those definitions, we feel like it's best to do it in a professional type of way. Hey, tasks that can be completed, right? Charles and Jamison also back that up. The top final stage of this is organizational AI. That is the top final stage. And what that means is it involves AI that is able to work as a whole organization, right? Make organizational decisions and things like that. So Lee, when you're talking about your checkpoints, is that kind of what you're seeing, at least, or envisioning it to lead up to? Is this powerful intellect, is that fair, that can run a whole organization from beginning to end?
I'd be excited to try. I do believe that I don't know if we'll ever truly achieve that level of AGI, right? As what we were talking about, I think it was even before we even started our session here, just from an accountability standpoint and making sure that, hey, if I have people working for me and I have a computer making the decisions, well, right, it can lead down some dangerous roads. I actually, if you don't mind, Rich, what I want to do is I want to take this question that you provided to me, and I've been burning to ask Jamison this. I've really, really wanted to kind of push it back to Jamison, because you were talking about how you have narrow AI, and then, of course, we have general AI, right? I was going to ask Jamison, is it possible to get to this, what Rich's question is it possible to take narrow AI and, you know how you would make braids, you kind of weave it all together. I have one strand of narrow AI. I got another strand. And I keep making these strands and I start weaving them together. Is it possible by doing it that way, that we could achieve this level of super intelligence, is something that I'm not sure on. I read a couple studies, but wanted to get your thoughts on it.
That's a good question. I think when it comes down to it, there are two different ways to go about considering how to construct a system like that. That is one way, basically, where you have a bunch of different bits and pieces of narrow AI. The other possible method would be to have one particular model that is trained on a whole bunch of stuff that is itself able to do a bunch of different things. Now, that's a lot more difficult, especially since we already have a whole bunch of different super intelligent narrow AI models and programs. But what it comes down to for that is the more different bits and pieces you have, the more you have to figure out how they're going to talk to each other. Because general intelligence comes from the interconnection between all of those little task-solving bits, and that comes down to the language and the protocols through which they communicate with each other, as opposed to having one gigantic module that is able to apply itself in a variety of different cases. So I'd say those are two different things. I'd say the organizations that we have nowadays, especially with Google, especially with what Google's doing with research right now, that's basically what they've been doing. They've been trying to create small little models that can do one particular task or one subfield of tasks really well, and then hook that up to other programs and models. And that I would say that's pretty much where we are right now. That's how I would define the capacity of intelligence for larger organizations. But when it comes down to a single entity, it all really depends on how well all the bits and pieces really interact with each other, I think. I think that would be my viewpoint on that.
Hey, Lee, can I piggyback on that? So those individual strands, could the larger AGI learn from each of those and then learn how to do those tasks? Could that be another factor? As we talk about, right? Machines will learn from other machines, and eventually, I think Charlie quoted this before, model collapse. But in this sense, in a positive way, it will learn from those individual narrow strands. Is that a possibility? Yeah.
That's definitely, that is one of the main ways that we tend to train models nowadays. Is we have one, like a particular model that's really good at saying this is real and this is not real. We use that to train generative models all the time. That's pretty much the basis behind the method called generative adversarial networks. So that's definitely something that we can do. What really comes down to for that is it's the training process at that point, right? And when you're trying to make a large model that can do a bunch of different things, you can use a bunch of smaller models to help train it. But again, that complicates the training process more. So it comes down to how much do you want to spend on training a particular model? How feasible is it to have that model be trained by a variety of different narrow models? Or how much do you want to spend on creating protocols that allow those different models to communicate? And really it comes down to scalability, because the more narrow models you add on to either of those methods, the more difficult the problem becomes.
Interesting. Leo, I want to give you a second to respond to that.
I mean, really, my mind is reeling, listening, Jamison, to what you're saying. And I'm just liking it to right now. So my son is 2, right, going on 3. And I'm just thinking about how I'm explaining colors to him right now, right? And I'm giving him Roy bit, basically, right? That's what he's getting right now. But then he'll see another color that pops up. That's brown or gray, things that he hadn't seen before. And I'll say, hey, what color is that? And any color that he doesn't know, he automatically assumes it's black. That's just where his mind is, right? He'll just call it black and then keep moving. So I'm wondering, from what you're saying here, you can set this up. You can set it up with all these different narrow models. But when something pops up that it doesn't know, how does it classify it? And if you're getting one level of classification from one model and something that is conflicting in another model, then now what do we have? We have a piece of intelligence that is very, very difficult to understand. So that's just something I was thinking in my mind, because really what we're trying to do is we're trying to grow a child into a human, but we're doing it from a standpoint of a computer. So that was just, it's reeling in my mind right now. So I just thought I'd respond with that, because that's where I am.
Perfect. Okay. Thank you for that, Lee. And Jamison as well with the explanation. So let's jump to our next question then. Singularity. It is a term that was mentioned actually earlier in here in our discussion today. It is one that we hear a lot associated with AGI. I'm almost nervous to pass this over to you, Charles. Charles, can you explain to me and the audience here, what is the singularity?
So let's start off with what a singularity actually is. In a mathematical context, I believe I've mentioned this on a podcast before, a mathematical singularity is a point where predictions fail. You may have heard the astronomical phenomenon. A black hole, a collapsed star, has a gravitational singularity at its center. It's called this because it is too small for general relativity to make accurate predictions, and it's too heavy for quantum mechanics to make accurate predictions. If you're a physicist, pretend you didn't hear that. But essentially, it's a point. It is mathematically, a singularity is a point where predictions fail. You try and calculate what is the limit of 1 over x as x approaches 0. You can only calculate the limit. You can't actually calculate the number. It's undefined. So a technological thing, this has been, let's just say appropriated by this community to describe what happens where technological predictions fail. And generally, it's going to be a technological advancement that makes predictions before that advancement impossible. Before the iPhone, people could not predict what the world would be like if you had a computer in your pocket at all times. The more enticing, I suppose, technological singularity that most people talk about is the point where machines can augment their own intelligence. And so this is a principle that enthusiasts of this community call an intelligence explosion, because a machine can make itself smarter, and it can use that same tools to make itself smarter in the next generation and the next and the next. And the idea is that it is impossible to imagine what this machine is capable of because it is smarter than any human can possibly be. I will just say that this notion is rather more fanciful than AGI. AGI typically, as I mentioned, AGI typically has kind of business and social implications. The technological singularity is more philosophical. And this is a part that I keep coming back to. It is based on nothing. Like, we assume that it's possible to do that, but we don't have any evidence. And the argument goes that this poses such an existential risk that you have to assume it's possible, but it might not be. There might, yes, sure, it is possible to have accelerating returns to intelligence. It's also possible to have accelerating returns to software bugs. And so as a machine compounds its own intelligence, so much of that intelligence has to go to correcting errors in the previous generation. The singularity is something that might happen. There might be some physical limits of the universe that we don't know about. When we're talking of, so when you hear the term technological singularity, it is extremely speculative. And any person who speaks with authority on the singularity is by definition just making things up.
I'm going to leave it there. I mean, you summed it up perfectly. That's what I was hoping to get out of that. I'm going to jump over to Jamison. The question I'm about to ask you is one that when you were at one of the Ivy League schools presenting, the alignment problem was one of those kind of after the course ends, people came up and spent the 20, 30 minutes extra as you're explaining it. We have the singularity well defined. Is this along the lines, an issue, I guess you could say, with the alignment problem? What is the alignment problem? And maybe Asimov's law of robotics as well.
Yeah, those tie into each other pretty interestingly, and as well with the singularity topic. It's a great segue, honestly. So when it comes to AI alignment, that basically just means being able to get whatever particular model that you are using for whatever particular task, to get that model to do that task consistently in a ethical manner. This definitely ties into safe AI and ethical AI as well. Now, bringing things back to narrow versus strong AI. Narrow AI, it's very easy to align a particular narrow model with a particular task because it's really only doing one specific task, right? You don't have a gigantic problem space that you have to define for the model. You have this particular thing. It's easy to create a data set for that particular thing. It's easy to create benchmarks for that thing. And it's easy to evaluate the model to ensure that it is doing the correct thing. And when it comes to aligning that kind of AI, it's not too difficult, honestly. But when it comes to generalizing that, there are a couple of different problems that come into play, honestly. Making a model robust, which basically means making it able to efficiently handle data that it hasn't seen before, that's basically just applied to one particular task or problem, right? When you really are just applying it to that particular task, again, not too difficult. When that problem space starts to expand and you start trying to apply it to a bunch of different tasks, that's when model flexibility comes into play, using particular data and being able to process that data and still achieve the outcome that you want to align that model with your own intentions. That's when things start to get a little bit more difficult, because that's when you start to generalize that model. And it gets even more difficult when you start putting it into completely different problem spaces that use completely different data, right? And that's the whole point of AGI, is to be able to do that in a way that is still ethical and safe. And we are already running into a lot of issues with that because, for one example, the models that we consider the most AGI-like right now, the large language models, they take a lot of data, right? The image generation models, they take a lot of data. Where are we getting that data from? That's when the ethical side comes into play in the process of aligning that model with the human level side of either creating images, creating art, creating conversations. Whose stuff are we using there? Is that particular person getting credited? Obviously, of course, this is a huge problem right now, but it's really only one tiny problem when it comes to the entire process, right? And it exponentially becomes more difficult the more general you're trying to make a particular model in most cases, because the entire process becomes more convoluted, right? How do you expand a machine that is made specifically for, I don't know, putting toothpaste in toothpaste dispensers? How do you expand that to the point where it can make an airplane, right? There's a whole bunch of different things that go into it, right? It's probably not just the physical aspect of what the machine is doing, what it's made of, its instruments, but also what the process is for making an airplane as opposed to putting toothpaste into a toothpaste dispenser. It's completely different, right? And how do you evaluate that entire process as opposed to, great job, you filled up the toothpaste dispenser? There's a whole bunch of different things that go into it. And that's the entire problem with intelligence as well, with trying to measure intelligence in a way that we can actually rely on. That's difficult, especially when we don't actually have a good definition of intelligence ourselves. And that's actually the second part of the paper that I mentioned previously on the measure of intelligence. That's where Francois Chalet starts to actually introduce new data sets and new benchmarks for applying that. So the process that we're in right now in terms of alignment is still very human-centric, and it should be, obviously, because we're not even close to superintelligence generally yet. But what it really comes down to, I think, is making sure that we're able to create benchmarks for what we're testing for. And when it comes to general intelligence, those benchmarks have to be extremely robust. And the more general a model is, the more likely it's going to do some weird stuff when it's given a new problem. And the difference between humans and machines is that humans have a lot of prior knowledge priors even is what it's called, when it comes to just interacting with the world, right? There's a lot of stuff that we do intuitively, as can be seen with intelligence, right? That we don't really completely understand. And we can't actually port that kind of intelligence over to machines until we actually understand it and we can evaluate it reliably. So, go ahead, Rich.
Yeah, what I ask you on the alignment piece, there is a famous scenario with a paperclip making robot, correct? Do you mind humoring us real quick and kind of telling us what happens when that alignment is not aligned with a paperclip making machine?
Right. That's an excellent example. So correct me if I'm wrong, Charles might actually have a better insight on this than me. The paperclip making example is there's a robot that can make paperclips. It's really good at making paperclips. But when it's given the power to make the paperclips in the most efficient manner, the company that owns the robot is basically like, we give you as much jurisdiction as you want to figure out how to make these paper clips as fast as possible, how to output them, and you can do whatever you want to do that. The robot ends up just destroying humanity in general, I believe.
Yeah, runs out of materials, and then starts using the machines and buildings around it, and then runs out of all the resources, and then I believe starts using humans in some form or fashion. Charles, I saw you come off mute. You want to add to that? That's kind of where it goes down, right?
The phrase is, the AI does not hate you, nor does it love you, but you are made of atoms, which it can use for something else. So the paperclip maximizer scenario is a generally intelligent superintelligence that is given the task of making as many paperclips as possible, and it converts the entire mass of the universe into paperclips. And this is one of those AI doomsday gray goo scenarios. And I'm going to say, I think this betrays a fundamental problem with how we think about AI, which is we treat them like genies, where the myth of the genie is that you wish for something and the genie is malicious and it follows the exact letter of what you said rather than doing what you wanted. And so many of our AI doomsday scenarios are predicated on repurposing fairy tales, if I'm going to be rude.
Of course. This is the boogeyman, the new version of a boogeyman.
Yeah. And in fact, you mentioned Asimov's 3 laws of robotics. If you actually go back and read the robot stories, pretty much all of them are about a robot that followed the letter of the 3 laws to just do what it wanted anyway. The point of Asimov's robot series is that the 3 laws don't work. An intelligent agent will just do what it wants anyway, regardless of what laws, regardless of what, 3 rules you give it. I should mention that in general, Asimov was writing about generally positive outcomes. So it was robots that were bending the three laws to help people in certain ways that the three laws would have forbid otherwise. So we look at scenarios like the paperclip maximizer is an excellent rhetorical talking point because it's quick, it's simple, people get it. But the actual problems of AI are going to be more nuanced than that. You're probably at some point, the paperclipper is going to fail to understand what a paperclip is and turn the universe into gray goo in some other way. But again, a paperclipper is a good thought experiment for this. But I do have to mention that when we're talking about a system that takes many disparate threads of intelligence, allocates resources to them for a single inscrutable goal without concern for the external impacts of that goal, that's a corporation. That is, we already have that. Look at all of the horribly unethical lithium mines and cobalt mines in the world that are exploiting vast numbers of desperately poor people to make graphics cards that make our models work. We are paperclip maximizing the planet into graphics cards, while the people doing this are telling us it's to avoid making a paperclipper. I'm just saying.
And I'll tell you, to hear more about that from Charles, he was just on a podcast where he was talking about energy consumption. And when you're referring to these people saying that to become the paperclipper, you're also probably referencing Bill Gates' comment where he mentioned that don't worry about energy use with AI or AGI in the future. AGI or AI will find that solution. And you refer to that as magic. If you don't mind, I want to keep in mind as you guys are on a tear and killing it. I want to talk a little more positive though, if we can dive down in there, right? And Lee is somebody who always personally cheers me up. Let's help cheer the audience up here. What are some positives that AGI can bring to humanity?
Yes, there are so many. It's super fun to talk about. The major positive to AGI for me, you're asking me, problem solving. I think that would be an awesome application use of AGI. And you ask, Lee, are we talking math? Yeah, maybe to a degree. But I'm saying from a multidisciplinary. So eradicating diseases, I think this is something that we were talking about before, being able to understand genomes and break it down at a level that, as Jamison, you were talking, 100% smarter than all humans. Let's get that as best we can. So eradicating diseases, environmental sustainability, something that could be done, disaster preparation and response. So if you're telling me that building a technology that can cure cancer, for example, that would be on the disease side, optimize natural resources, which you were just talking about just a moment ago here, and then improve disaster preparedness to minimize the impact of hurricanes, floods. Shameless plug, there's a good movie out, Twisters, right? They kind of work on that. I mean, the technology that they're doing, the goal of using that technology is to, well, I don't want to give away Twisters, but
I gotta know what happens. I don't even know what happens in the movie. I'm
all
seeing
right. Basically,
a Twister or two.
We got twins. But in that case, yeah, I'd vote for that. So, but outside of just problem solving, you have enhanced decision making skills. I think that would be there. Companies would love that for sure, as well as people. And then environmental sustainability, you have education. I think I mentioned healthcare, security in the good way, not Skynet, but security would be great. And then entertainment and automation of labor. So I think all these things are good. I could see some people coming in and saying, well, Lee, on the entertainment or on the automation of labor, people are going to lose their jobs. Yeah, they are. They absolutely are. If you do not take this technology and use it to your benefit to help you in your own world, you're going to get beat out by somebody who does. But same thing would have happened for the person who is against using the wheel, right? Okay, it's going to be it's going to be a tough road when it comes to pulleys. These type of things, that's what I think about. But hopefully, I think these will be some excellent positive outcomes of utilizing AGI as long as we have the right actors involved.
That's amazing. You're right. There's always going to be job displacement. There's going to be job creation, right? Ideally, this produces more streams of economic growth that benefit us all. I also want to highlight, I love the disaster recovery. Imagine, we talked about in the beginning, the drones, and be able to turn on a dime all as one unit to handle something in a military setting. Imagine that as a firefighting brigade, or being able to provide support or medicine to those who it can't reach. Now, that's occurring on a very small basis currently, but on a grander scale in disaster relief would be outstanding. Overall, just kind of going back to it, that's why we also need to make sure that the concentration of power is dispersed, right? It's not just the Microsofts and the Googles and that own all of this, because then that's where the control is. And it doesn't go into those areas unless, back to Charlie's point about corporations, unless it is making money, right? But Lee, I mean, that is incredible. Overall, poverty, disease, environmental areas that we can't even fathom. Excellent. Thank you for that. I want to keep a little bit on time. We have 2 remaining final questions. And Charles, a little bit more succinct on this one. Does AGI have to happen? I know it doesn't. Good. That's as succinct as you can get.
Well, I just kind of want to say intelligence, sentience, sapience, consciousness. These words are often used interchangeably, but they all mean completely different things. You can have intelligence without consciousness. You can have consciousness without intelligence. You're not going to
go through them all?
I'm not going to go through them. But a thing that's worth considering in our current models, the astronomical and exponentially increasing power use and resource use of the way we model intelligence, it might not be possible to have a generally intelligent system that is capable of holding all of the interconnected nodes of reason that will make a generally intelligent system. If we discover that narrow intelligence is cheaper and more efficient, we're going to pursue multiple narrow super intelligences rather than one general intelligence. Now, I'm not saying that is how things are going to shake out, but I think it is entirely possible to imagine a scenario where it does. It doesn't necessarily have to happen in this specific way.
You know what, Charles, and that really tied a lot of what we just discussed. You can see the responses by, I think, the three of us over here while you're saying that. That makes a lot of sense. I mean, we're burning through resources right now. So something at such a grand, seemingly unimaginable scale of consumption, it just might not be there. It might turn into that paperclip thing. And in reality, and then so you're talking about all these different narrow super AIs. That's something, right? And I think I wouldn't understand that sentence without chatting with you all today. Sorry to cut you off. Did you want to add anything else to wrap that up?
Yeah, I think we are at a very, we're kind of at a uncertain transition point in the field right now. And I think, and there might be even an economics question. OpenAI has burned through $5 billion, and it's not profitable. It's running on hype and investment. And there really isn't a path to monetization for this. Yes, OpenAI has some lovely chatbots. They don't make a lot of... ChatGPT has some lovely chatbots. They don't make the kind of money that it's necessary to keep, this research rolling. So there might be a point where the research stops based on funding. Goldman Sachs has recently come out with a report that says they doubt that these companies can ever be profitable, that they're overestimating the reduced cost to train models. And there's a lot of economic analysis that might slow down this research. Or the other transition point is there is a technological innovation where they fulfill all of these promises, and there's new excitement, new investment, and research continues. I believe the phrase Jamison has used a lot, AI winter. Do we hit another? There's a point where there's an explosion in excitement as there's new technology, and then it turns out it's really, really hard and expensive to monetize it, so research falls off. What part of the cycle are we at now? That's the question.
And we've seen it on a smaller scale with the metaverse, right? It ended up being too costly for Meta, and they basically had to trim that down because their stock was going the opposite way of AI stocks right now.
Mm-hmm.
Right? So all great points. Let's go to our final question. Jamison, what technology is needed to get to AGI? Is there more theory needed, or is it just a stronger technical capability that we require to get to that stage?
I'd say yes, in general. Both for sure. I think they kind of go hand in hand. For sure, there's theory about the actual technology that we haven't understood, but there's also theory about cognition in general. I mean, the cognitive revolution only happened in like the 70s and 80s, right? And that's when we started realizing, oh, hey, we can generalize these models to make something more intelligent. But I think in a lot of cases, when it really comes down to it, what we really need, first off, is for these models, if we're truly trying to align them with human intelligence on a grand scale, we need them to have the same kinds of inputs as we do. And we are not really even close to that yet. We have them understanding vision. Computer vision field is huge just because we have a lot of data for it and we understand how vision works on a very fundamental level. Language is another one because we understand how it works on a fundamental level, and it's more surface level than a lot of the deeper styles, sensations. But when it comes down to being in the real world, I think that's where intelligence really comes into play, because the real world is what presents you with new scenarios. Humans are not very good at presenting these models with truly new scenarios to make them robust, to make them flexible, to make them generalize. That has to happen on their own. And there are a lot more steps that we have to get to, that we have to actually completely overcome before we can truly say these things are generally intelligent. Because it really comes down to what they're feeling. Not necessarily emotionally, but what they are sensing, right? And how they have the power over themselves to be able to sense those things, to focus on particular sensations and understand the different objects in the real world and how they interact. We're not there yet. Another aspect is how they develop. We control the training process entirely. It is entirely human-centric, which is in some ways a good thing, but it's also, if you take humans out of the picture, models don't exist, machines don't exist, right? They are an extension of us. And so when it comes to AGI, if we're using the definition that we are comparing artificial intelligence to human intelligence, as we make these machines more intelligent, we ourselves on a whole become more intelligent. And so it's sort of a game of catch up, right? But it's a bit of a paradox a little bit in that regard when it comes to, is this machine more intelligent than the average person? How does that work when the average person's intelligence is going up year by year, right? Mm-hmm. It really is just kind of a game of cat and mouse, and I think it honestly always will be. It's an ongoing process, and the goal in general is AGI. But we have to worry about how those machines develop. We have to worry about how they sense, how they process all their own stuff. And that is both theory and technology, applicable technology. So I think we have a long way to go. but I think we are continuously making interesting steps that shake the foundations of humanity in general and will continue to do so into the far future.
That's incredibly interesting. A great way to kind of wrap up our discussion here. I do have two simple ones we'll wrap up with fully. But Lee, I know you mentioned you had a question that you wanted to pocket. We're towards the end of our discussion here now. Did you want to bring it up?
Yeah. Charlie, I was kind of listening to what you were saying, and then Jamison, you kind of touched upon it as well. I wanted to pose this question to the team. Do you think if AGI could solve existential crises, that the government would want it to?
Tinfoil hat back on, by the way.
You know what I mean?
I think it depends on the government. It depends on, because like a government could either be people who are interested in government for the power it grants them, or boring civil servants. The government has a lot of both of those. And I feel like the civil servants would be very interested in a system that can solve existential crisis because it makes their jobs easier. Whereas people who are attracted to government for power would not want that because it takes away that power. So support boring civil servants. The more boring, the better.
Yeah, that's what I'm thinking that. And I'm thinking what Jamison and Rich were talking about as far as the AI winter. You know where my mind went immediately? I'm thinking about AI winter. I thought immediately about the Cold War. Immediately. First thing that came to mind. And then I started thinking to myself, when did America stop looking up? Like, the benefit of the existential crisis is that you need the government, right? That's a benefit of it. And then likewise here, if we're talking about AGI, if we are in an issue with another country, this will perpetuate and it'll stay high on the list. That's why, space exploration has stopped, right? When was the last time we went to the moon? Stopped all that ahead
Early
of time.
70s? Go ahead, Charles. You know space better than anybody here.
Well, the unfortunate reality is that it is literally astronomically cheaper to send a robot into space than it is to send a person into space. Like, NASA has landed like 7 robots on Mars, and 3 to 4 of them are still going. The cost of sending air, food, water, sewage, filtration, just to keep a human being from the context of space exploration is like 6-foot meat sack to keep a few pounds to keep a few pounds of interactable material alive. The robot can just be this part. So the reason why human-driven space exploration has kind of fallen out is because robots are so much cheaper. And generally intelligent systems will make our space robots even better. Why? Because it takes like 8 minutes to get a light signal out into deep space. And having a system that is capable of making decisions on site would be an incredible boon for planetary exploration.
I think that's one of the things I'm most excited about, space exploration for AGI. Lee, to your point, I think one of the first things we'll see, instead of going to the existential crisis realm, I'll be interested to see what is created through the sciences and how does that get potentially blocked or released to the civil servants, as Charles was mentioning. That, and then, I think that's my biggest checkpoint for me that would lead to probably that answer of your question, personally. Cool. Gentlemen, this has been a blast. I have 2 questions for you. If you don't mind answering in fairly short sentence or even one word. The first question to you is, will AGI happen? Just one word or so. Jamison?
It is, and it will.
Excellent. Charles?
Eventually.
Okay. Mr. Evans?
I say we'll get 99.9% there.
All right. My last question for you, a little more personal to some extent. Is the juice worth the squeeze? Do you want it to happen? Lee?
One answer, yes.
Okay. Charles?
It depends on the environmental impact.
Okay.
AGI is valuable. If we burn the planet to cinders to make it, there is no point.
I don't think many people are going to disagree with you there. Jamison?
Personally, I love technology. Any new technology is fantastic, especially if it's mimicking brains, because I also love brains, for sure. I think impersonally, it doesn't matter if we want it to or not, because it is happening and it will happen continuously, as long as we exist as a centralized or decentralized species.
I love it. Guys, there is so much information that each of you shared and put some things together. Overall, I loved watching this. I hope to have you all back again. Thanks for your time, everybody. Have a good one.
Thanks, guys.
Bye, everyone.